My name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 277. Page 277, or rather page 278. Page 278, and today is our lesson number 50. Let's take a look at it. Problem number 80 is what we're going to do. I'm just going to change in my notes here. I have written down 277. It is 278. Problem number 38. Here's what's going on. Read the problem to yourself. Problem number 38. We have a scientist who goes around looking at the bird nest, and he counts how many eggs there are in each of these birds' nests that he examines. We are told that he has examined 10 bird nests, and he has recorded the number of eggs in each of these 10 birds' nests. The question simply is, what is the standard deviations of these 10 observations? The first statement tells us that the average of this 10 nests was 4. On average, there were 4 eggs in these 10 nests. Average tells us absolutely nothing at all about the standard deviation. Standard deviation has to do with how they are spread around the mean. Knowing the mean itself doesn't do us anything in terms of knowing the standard deviation as to how these observations are spread around the mean. This information is useless. Not enough. Well, I shouldn't say not enough, because not enough has the nuance or the implication of the fact that some of that was useful, but it's not enough. No, that's not it. This is useless. This is useless information. Knowing the average does not tell you anything at all about the standard deviation. One needs the average. I suppose I should say not enough. I suppose I should say not enough, because one needs to know the average in order to calculate the standard deviation if one has all the observation. Because it is the difference. It is the difference between the given observation and the mean of the observation that plays role in the calculation of standard deviation. But simply knowing the average itself does not tell you anything at all about the standard deviation. It is not enough. A, D, B, C, E. Since the first statement by itself is not enough, answer cannot be A, nor can it be D. Let's look at the second statement. In the second statement, they tell us, this is a very ridiculous question actually. Look at what they tell you in the second statement. It tells you that each nest had same number of eggs. Well, if each bloody nest has the same number of eggs, if everybody has the same number of eggs, and the average was, well, actually we can't use the average, so we don't even know the average here. But if they all have the same number of eggs in each of the 10 nests, then standard deviation being the spread around the mean, there is no spread. They are all the same. The standard deviation, of course, is 0 here. Standard deviation is a big fat 0 because there is no deviation from the mean. There is no deviation from the mean because they are all the same. And since if they are all the same observation, then whatever these observations are, each one of them individually being the same one, that observation, that value that is your mean. And there is no deviation from the mean because they are all the same value, the value of the mean. The standard deviation is 0. So the second statement does the job, which means the answer is B. Let's do one more, shall we? Let's do 39. This was too silly. Some questions are too silly, and one doesn't know how much to explain these things because it's too simple, it's too obvious. I mean, if they are all the same values, and then one asks you what is the standard deviation, well, there is no blasted deviation. They're all the same. You just told me that. So they do not deviate at all from the mean. The mean is the value of each of the observation. Number 39. We are told that we are holding 12 cards and we are told that the cards are either red, white, green or blue. Red, white, green or blue. The question is the odds of picking either a red one, let me read the way they say it actually. Number 39. Terry holds 12 cards, each of which is red, white, green or blue. If a person is to select a card randomly from the cards Terry is holding, what is the probability that less than half that the card selected will be either red or white? Is the probability less than half that a card selected at random will be either red or white. Now you see this entire sentence written out in English language. Question is, how do the mathematician write this entire sentence? This entire sentence will be written mathematically as the probability of selecting either the red or the white. Does that equal half? With the question mark. Does that equal half? There you go, that's your question. Let's find out what they tell us. In the first statement they tell us that the probability of selecting a blue is 1/3. Probability of selecting a blue is 1/3. What does that tell us? Probability of selecting a blue is 1/3. That implies that there must be 4 blue cards, because 4 over 12 is 1/3. If the odds of selecting what was it, red or white, does that equal half? If the probability of selecting a blue one is 1/3, and since there are 12 total cards, 4 divided by 12 is 1/3, which means there must be 4 blue cards. But that tells us nothing at all about the odds of picking either red or white. As a matter of fact, it doesn't even make any mention of red or white. It just talks about blue. It's not enough by itself. A, D, B, C, E. Since the first statement by itself does not do the job, answer cannot be A or D. It's got to be either B, C, or E. Let's look at second statement. Second statement tells us that the odds of picking a red one is 1/6. If the odds of picking a red one is 1/6 and there are 12 cards altogether, that implies that there must be 2 red cards, because 2 out of 12 is same as 1/6. We know now that there are 2 red cards. We know nothing as to how many white cards are there, because we need to know the white. Here we just know that there are 2 red cards. We do not know how many white cards there are. Therefore, second statement by itself also does not do the job. Answer cannot be B. If we put them together, we should see immediately that there is no way we can figure out what the odds of picking a red or white is, because neither of those two statements make any mention at all of white. And since we do not know how many, either we need to know how many white cards there are out of 12, or we need to know exactly how many blue cards there are, how many red cards there are, and how many green cards there are. If they had told us the odds of picking a green card, and the odds of picking the blue card, and the odds of picking the red card, then of course we can figure out how many white cards there are. But there is no way of figuring out the white card, because we don't know. Altogether there are 4 of these and 2 of those. That's 6. Which means the remaining 6 are, let me do it on the top. So if you put them together, that implies that the remaining 6 are white or green. But we do not know the split. We do not know the split. And since we do not know the split, therefore, since we do not know the split, therefore, the odds of picking either red or white, odds of picking either red or white could be greater than, equal to, or less than half. It could be greater than, equal to, or less than half. And if you're curious, I'm going to show you all three of those scenarios. I need the room, so I'm going to erase this thing. The question was, is the odds of picking a red or white car less than half? And we'll show now that it could be less than half, more than half, or exactly equal to half. For example, here's your white card, here's your green card. If the split is 5 to 1, then the probability of picking a red card or white card, we already know that we have two red cards. We already know that we have two red cards, and we already know that we have 4 blue cards. Although this plays no role, we're not interested in blue. There are 2 red ones. So if there happens to be 5 white cards and 1 green card of the remaining 6 cards, in that case the odds will be, since there are 5 white cards and 2 red cards, is 2 plus 5 out of 12, which is 7 out of 12, which is more than half. If it happens to be 4 and 2, if we happen to have 4 white card and 2 green card, then the odds of picking the red card or white card would be, there are 2 red cards, 4 white cards, altogether 6, and now it's exactly equal to half. If it turns out that the split is 1 to 5, if there is 1 white card and 5 green card, then the probability of picking a red card or white card would be 2 plus 1 over 12, which is 1/4, which is less than half. We cannot tell because we do not know the split between the remaining two cards. All we know is that there are 6 cards left, and we know that those 6 cards are either white or green, but we do not know how many whites and how many green, so it cannot be done. So putting the two together still doesn't do the job. The answer is E. The answer is E. Alright, I'll see you tomorrow, okay? Bye now.